Hi everyone, welcome back. Today I'm going to explain how to find the area of the shaded portion between a regular hexagon and a rhombus. I'm going to share my screen. You should be able to see the diagram, which I just described. So let's get started. Sorry. A quadrilateral is drawn inside a regular hexagon as shown. Two vertices of the quadrilateral correspond with two of the hexagon's vertices. So these 2 points touch each other, and the other two vertices of the quadrilateral correspond with the midpoints of the opposite sides of the hexagon. And that's talking about this point right here and this point right here. So they bisect. They're in the middle of that side. And if the sides of the hexagon are 10 centimeters long, in simplest radical form, what is the number of square centimeters in the shaded area? So we have to find out the area of the shaded portion, but we only have our side lengths of the hexagon. One method you could try to solve this with is you could find the area of the hexagon and subtract the area of the quadrilateral to find the shaded area. But that wouldn't work because we don't have any information on the quadrilateral right here. So that would be a no. But we do know that not only are the shaded portions in between the two shapes, but they are triangles. And we know that the formula for finding the area of a triangle is half times base times height. So maybe if we find out the height of the triangle, this length, and find out the base of the triangle, which is this length, we can find out the area of the triangle and times it by 4 to find out the shaded region. Okay, so let's get started. First, we should find out the base of our triangle. Let me just draw out a triangle right here. So it looks something like this, an obtuse triangle. And we want to know this length right here. To find out that, we just have to look at the problem. In the problem, it states over here that the other two vertices of the quadrilateral correspond with the midpoints of the two opposite sides of the hexagon, meaning that these points right here marked in green are dividing the side length into two equal pieces. And because our triangle is half of the length of this side, 10, we can just do 10 divided by 2, which gives us 5. Therefore, the side length right here, the base is 5 centimeters. Now that we know our base, we need to find our height, which is this value right here. And notice that I'm not taking the side length of the triangle itself, but I'm taking the actual height, which is important because that's what's going to give us our area. So in order to find the area of our triangle, we also, in this case, it's also known as the apothem because the triangle's height is equal to that, since the triangle's point right here is even with the midsection of the hexagon. And to find the apothem, let's divide our hexagon into 6 different triangles, like so. So I'm just going to divide it into triangles, 6 even triangles. And if we were to find the measure of the degrees in each of the centers right here, for all of the hexagons, we would just need to take 360 for a whole circle and so divide it by 6 for the 6 in triangles inside, and you would get 60. And and they're all 60 degrees inside. We can also say that these two right here are 60 degrees because the triangles all inside are isosceles. And we know that these two right here, 1, 2, they have to be equal. So because we know that a whole triangle's interior angle sums add up to 180, we can subtract 60 and we get 120. And then using 120, we can divide that by 2 to get 60. And that's how we know that these triangles are equilateral triangles. Yeah, they're equilateral triangles. Equilateral triangles have their measures all are 60 degrees. So because we know that it's an equilateral triangle, 1 second. Oopsies. Because we know that because it's an equilateral triangle, that all of the measures have to be equal. So let me draw out the same triangle right here. Because it's an equilateral triangle, we can say that all sides are 10, because since one side is corresponding to the measurement right here, 10, we can say that this side is 10, but we can also say that the other two sides are 10 because it's an equilateral triangle. Now that we know the side lengths of our triangle, let's divide it in half to find out the height. So dividing in half, and it's going to be like this in a right triangle. We know that this length is 5 because we're dividing the triangle in half, so 10 divided by 2. And we know that this side is 10, and we know that this is x. To find this out, we can use the Pythagorean theorem, or we can use the 30, 60, 90 triangle. We know that this is 90 degrees, and because we're dividing this in half over here, this was originally 60 degrees, so 60 divided by 2 is 30. This is 30 degrees, and this degree here we said was 60, and we're not changing that, so it just stays 60. And if you know about a 30, 60, 90 triangle, the height is always x times the square root of 3. And x is equal to 5 in this case, so our height is equal to 5 square root 3. So now that we know our height is 5 square root 3, we can plug it in to the formula we mentioned before, which was right here, to find out the area of one of the shaded triangles. Let me clear my drawings over here. So now let's plug it into our formula. Half times base, which is 5, times the height, which is 5 square root 3, is equal to the area. And let's just solve for that. So half times 5 times 5, the square, 5, oh my gosh, 5 times the square root of 3 times 5 is 25 square root 3. That was tricky to say. Then once we have that, we take 25 square root 3 divided by 2, which is 12.5 square root 3. And that's the area of one triangle right here. So this triangle is just 12.5 square root 3. And that's only finding one of our triangles right here. To find out all of the triangles, we take our value 12.5 square root 3, and we multiply that by 4. So our final answer should just be final answer should be 50 square root 3. I hope this helped you understand how to solve this problem. Just need to dig deep into the problem and look carefully at the diagram. Thank you for watching and have a good rest of your day. Bye.